Okay, hopefully this video will help you with the calculations for when we write it up on Monday. This is a different example where we're looking at the percentage of phosphate or eventually phosphorus in bread. So we're getting a sample of bread, just like we did with the fertilizer, and we're going to work out how much phosphate is in it by dissolving it, precipitating the phosphate by adding silver. The silver is going to be as silver nitrate. So we're adding the silver nitrate so that the silver and the phosphate will get together and make a precipitate. And we're going to assume that all of the phosphate in the bread is sodium phosphate. So the first thing that you need to do all the time is write a whole balanced reaction, precipitation reaction. So you need to be able to write precipitation reactions. I've given you the formulas, but you'll need to be able to write a balanced formula if I wrote it in words. So sodium phosphate from the bread and silver nitrate that we're adding. The ions mix, so these cations and anions will meet each other when we mix them all together. The silver and the phosphate will meet each other, and the sodium and the nitrate. So when sodium and nitrate meet each other, they're still soluble, so it's still aqueous. So you must make sure you put the states on when you're writing balanced reactions. So AQ means it's floating around in water. When we put them all together, the silver ions and the phosphate ions, when they meet, they form the precipitate, the solid. So precipitation reaction has the solid written on it. All of these are balanced formula. So the numbers under here are when you have the right number of sodium for this phosphate so that you have a balanced formula. When we balance the entire reaction, you just put the numbers at the front to show how many you need of these for those. So the numbers at the front will be different depending on what is reacting with what. It's best just to start with the first element and balance it. So we've got sodium. We've got 3 of them here and only 1 of them here at the moment. So we need 3 of these sodium nitrates, which fixes our sodium, but immediately look at the thing that is with it, and you've got 3 nitrates now. So if you go over here, you see there's no number there. It means that there's 1 nitrate group at the moment, and we need 3. So we'll put a big number at the front to make 3 nitrates. That gives us 3 silver. If we go over here, we can see we've already got 3 silver. So having 1 of this whole thing means that we've got 3 silver, and that's fine. If we look at what's with it, we've got 1 phosphate, and when we go over here, we've only got 1 phosphate. Okay, so it's a 1 to 3 to 3 to 1. They're the ratios between them. It's good to kind of highlight the sodium and the nitrate we're not worried about. It's the silver ions that are catching the phosphate from the bread and making silver phosphate. So that's actually what we're interested in, just those ions. And that ratio between the phosphate in the bread, the sodium phosphate, and the silver phosphate is a 1-to-1 ratio. So sometimes it's good to just write the Ionic equation, and then you can see the silver. I've written the silver first because when we write the formula we put the cation first. So we need 3 silver. When you do an Ionic equation, you show the charge on the ion and you show the charge on the phosphate ion. So there's a 3 minus charge, which means that's why we need 3 silver ions to balance the phosphate. Okay. Okay, so the solid is what we're interested in. All the other ions that don't form the solid, the sodium ions and nitrate ions, they're still floating around. So they're called spectator. Spectator is like when you go to the tennis and you're watching a game or something, you're not participating. So that's why we can leave them off with the Ionic equations, because they're really not doing anything. They were soluble to start with and they're still floating around. Okay, it's good to do a flowchart of the steps, and you know how many steps there are, and you know what you're trying to find and how to get from one thing to another. So what we're trying to find to start with is what percentage of our bread is phosphate. So you're just making a fraction. You've got the mass of the bread. So if this was 10 grams and you had 5 grams of that was phosphate, then 5 out of 10 is a half, or 50% if you multiply it by 100. So if you have 5 grams in 10, you've got 50% phosphate. So once we know the mass of the phosphate and the mass of the bread, we can work out what percentage of the bread is phosphate. So we need to know the mass. We're going to weigh the bread to start with, and then we need to work out the mass of the phosphate. So to work out the mass of the phosphate, we need to know the number of moles of phosphate. Once you know the number of moles, you can multiply it by the molar mass by looking up the molar mass on the periodic table, and that'll give you the mass. So you need to know how many grams per mole you need for the molar mass and how many moles, and they'll cancel. So to get the number of moles of phosphate, we are doing the ratio between phosphate and silver phosphate. I could write the sodium in here because it's still a 1-to-1. So you can cut the sodium phosphate down and just talk about the phosphate part of it, looking at the Ionic equation. So to get the number of moles of phosphate, we're relating it to the number of moles of our precipitate. So once you know this number of moles, then it's exactly the same number. So to get the number of moles of precipitate, we need to know the mass of the precipitate. We need to weigh it and then divide it by its molar mass to work out the number of moles. And to get the mass of the precipitate, this is the last step. We have weighed our Buchner funnel and filter paper, and we've done that to start with, and now on Monday we're going to weigh it with the precipitate. So if you just take this mass away, then you'll be left with the mass of the precipitate. So that's the first step that you have to do in your calculations on Monday, and then just work through these 5 steps. Okay, so this particular example, this is the method. So our mass, so you need to highlight whenever you see a written questions, highlight the information that's important. So we've got, that's our mass of bread that you'll be using right in the very last step. And if you read through, you're pounding it up, dissolving it, filtering out the insoluble things that don't dissolve, and then collecting all the ions in the solution. So you've got lots of other ions, including the phosphate that we're interested in. Then you're adding excess, more than enough silver to collect all of the phosphate, adding it slowly so you don't trap any of the other ions, and you're allowing it to settle, testing it to make sure you've with a bit of extra this silver, make sure all the phosphate's precipitated. Then you're going to filter and collect the silver phosphate. So you need to weigh your Buchner funnel and filter paper before, and this example you've recorded the mass of that. Then you're filtering it and collecting your precipitate, washing it to wash off any ions, and then you're drying it to get rid of the water. And then the next day you're weighing it, and then you're going to repeat the weighing after drying again. And if the weights are exactly the same, they haven't changed, then you know that it was totally dry this time, and you've just confirmed that by repeating it. So you weigh it to constant mass when the weight doesn't change. So once you've got your weight and you know it's not changing, it's totally dry, then you're calculating the percent phosphate in the bread and the percent phosphorus. Okay, so like I said, we need to work at the first step, work out the mass of our silver phosphate precipitate. So this was the mass of the all 3. This is the mass when it was just the Buchner funnel and filter paper. So you've got, when you take it away, you've got 3.02 grams of your silver phosphate. Step 1, now we need to turn that into the number of moles of silver phosphate by working out the molar mass. Be careful when you're doing these. If there's a number here, if it's a 2 here, then you've got 2 phosphorus, and 8 oxygen. Some people here, oh, not at this point, but later on. So the grams will cancel and you'll be left with the number of moles. There's 3 significant figures here. Zeros at the front of a number are not significant. As soon as you hit a number, it's significant, and any zeros between numbers are significant. So there's 1, 2, 3. So all these zeros aren't significant. So we have to write down 3 numbers. So now we've got the number of moles of our silver phosphate. We need to relate that to just the phosphate. So remember, we want to find this, and we've got this. So it's a 1-to-1 relationship. You put what you want on the top. So we want the number of moles of this, we've got the number of moles of that, and you write the numbers that refer to each. So it's a 1-to-1, simple one. So we take this over to the other side, it's divided on this side and multiply it on the other side. People are skipping this step and writing that up here. They're not even writing this in symbols, they're writing just the number. And they're writing just the numbers here, which is mathematically not right. Okay, so if you're going to skip this step, you need to write it like this in symbols and then put the correct number here. So we had, sorry, I'll go back. I've left off here the 1-to-1 because 1 times anything is the same number. So the number of moles of silver phosphate is the number of moles of phosphate. So that 0.00721 that we worked out before is the number of moles of phosphate. Okay, so now we've gone from this to this, and we can work out the mass of just phosphate. So the mass multiplied by the molar mass of phosphate. M equals N on this. So people here at this step, a lot of people are multiplying this by the first number in the molar mass and then adding this, which is mathematically wrong. Put this in brackets. You work out the molar mass first, one number, and then you multiply it by this. Okay? So work out brackets first. And you've got 0.685 grams. Alright, if this number is bigger than the mass of the bread, to start with, you've done something wrong, totally wrong. Either you've got, something totally wrong with the mass of the silver phosphate, maybe you didn't dry it at all, or maybe, something's gone totally wrong, or you've done something wrong with your calculations. So that number obviously has to be less than this. So at the moment, this is your mass of bread, this is your mass of phosphate. So out of the bread, you've got 7.67% phosphate in there. The rest of it's probably carbohydrates, basically. Bread. Alright, so to find, we've got 7.67% of phosphate. Would you expect the number of phosphorus, the percentage, to be lower or higher than this? So it would be lower, because if you're only looking at phosphorus, then you've lost the mass of the oxygen here. So you have a lower mass up here if it's just phosphorus. So flowcharts to find phosphorus out of the bread. It's exactly the same here until you get to this step, and now we're just relating the number of moles of silver phosphate to the number of moles of phosphorus. So for every one of those, there's one of these. So it's still a 1-to-1. So the number of moles of this is the same as the number of moles of this, that's the same number. So the only difference between phosphate and phosphorus is that you're multiplying it by the molar mass of just phosphorus to get this. Okay. Alright, so instead of having your 4 oxygen, we're just multiplying it by the molar mass of phosphorus. And remember to keep your 3 significant figures. So whatever's in your calculator, if the number before, we want this number, so this is kind of like 35 or 351, we want to round this up because 5 and above goes up. So if that was a 4, it would be rounded down to 3. Because this is 50 at all, anything 50 and above, it will go up. So up to 4 or 400. But I've left off these numbers because we only want 3. Okay, so that's the number of grams of phosphorus. When you put this in your doing this, when you write it down, you need 3 significant figures. When you're doing any calculation, you keep all the numbers. Okay, so all of the numbers that were here, you multiply it by 31, and then all the numbers that are here, you divide by 8.93. But when you write down your answers, you only quote 3 significant figures. So you notice it was 7%, 7 and a bit percent, and now it's 2.5%. Oops. Okay, so this was the mass of phosphorus and the mass of the bread again. Errors. Identify the effect of errors. There's lots and lots of errors, so you need to be able to answer questions about the types of errors. So if the precipitate wasn't dried correctly, what would happen to your percentages? So the mass of the precipitate would be heavier because of the water. So the mass of the phosphate or phosphorus would be heavier, so the percentage would increase. If the precipitate didn't form correctly and other ions were trapped in it, so if you did it too fast, you didn't heat it, and you didn't add any acid to help break up those precipitates, silver phosphate that had formed, if you trapped other ions in there, then you would be weighing the mass of the other ions too, so the percentage would increase. Some of the sample was spilt while filtering it, or it went past the filter and down in spilt, depending on which filtering you're talking about. So if it was the initial filtering, when you're filtering out the insoluble parts, you're not collecting all of this phosphate that's in the bread, and so you would have lost some, so the percentage would decrease. So there's a whole lot of errors. I'm going to ask a lot of questions, and based on your notes, you will be able to answer them or not. Okay, hopefully people can pass this.